Hello everyone, today we will solve a resultant problem. Here the problem states a steam engine is diagrammatically outlined in figure 15. If when the steam is turned on, the thrust on the connecting rod is 80,000 pound. When theta equals 15 degree, find the total steam load F on the piston and the vertical force N on the crosshead. The engine is not moving. To solve this problem, first we will have to find out where all these forces are acting on. We can see that all the forces are acting on the crosshead. And the question states that the connecting rod is pushed back to the anti-clockwise rotation with the force of 80,000 pound at a theta degree angle with the horizontal axis. So from the Newton's third law, we can say that every force has its opposite and same reaction. From that, we can draw a free body diagram like this. For the crosshead, the free body diagram would be here the horizontal axis and the vertical axis. The N force which is acting vertically, so we should put it at the top since it is pointing upward, and then the force F which is acting leftward, so we will take it as such, and then the connecting rod, since it is pushed back with the force of 80,000 pound, then it will create a reaction force equal to that in the opposite direction on the crosshead, so that would go in this direction, and this force would be 80,000 pound, and the angle it will make with the horizontal axis would be theta degree, which is for this math would be 15 degree. From this we can solve this math pretty easily. Since this engine is not moving, then we can say that at the crosshead the forces are in equilibrium condition. To solve this, let's take summation of f of y, where upward is positive, equals 0. Let's find out all the vertical forces here. That would be N, which is acting upward, minus the 80,000 pound. Let's put it here. And since it is acting with the theta degree angle with the horizontal axis, so it will make a sine 15 with the vertical axis, equals 0. Therefore N equals 80,000 sine 15. Therefore N equals 80,000 sine 15. That would be 20,705.52 pound. Then we will find out the summation of f of x, similar to the summation of f of y, or the summation of vertical forces. For the summation of f of x, or the horizontal forces, let's take the right word as positive, since we are finding out the value of f, so we don't want it to end up in the negative, equals 0. Here all the horizontal forces are F and working against it is the connecting rods force. We will put it in minus 80,000 pound. Since it is working with the horizontal axis at an angle of 15 degree, we will write it as cos 15 equals 0. Then F equals 80,000 cos 15 degree. Therefore, F equals 80,000 cos 15 degree. We will get 77,274.066. So we can write it as 0.07 pound. And that would be the solution for this math. Thanks for watching.